My name is Colin Downs. I'm a control systems engineer, and I work at the Energy Systems Integration Facility at NREL, a cornerstone in the U.S. Department of Energy's National Lab Complex. The ESIF, located at NREL's Colorado campus, was designed to research, develop, and demonstrate future-ready, secure, and reliable energy technologies. The ESIF hosts about 170 research projects a year, an output that's only possible with the safety, flexibility, and the efficiency provided by the operations team. That's why we've built a SCADA system from the ground up using ignition by inductive automation. We needed a next-generation system that could support some of the most advanced energy integration research happening anywhere in the world. The ESIF enables multidisciplinary research across electrical, thermal, data, and fueling systems, which can be integrated into real-world scenarios. Powering and interconnecting hundreds of high-energy devices requires bulletproof coordination and safety. When the lab's previous SCADA platform struggled to meet the demands of our rapidly evolving research, we decided to rebuild from scratch, with emphasis on safety and rapid deployment. This wasn't a small upgrade. Our new SCADA system includes over 52,000 tags, 11,000 historized tags, 171 screens, and interfaces with more than 100 PLCs of various brands, as well as a variety of Modbus devices and custom controllers. It runs across a high availability infrastructure with development, test, and redundant production ignition servers, all virtualized on a robust 4-node Dell VxRail cluster. Our lab never stops growing, so ESIF engineers build new tools to keep pace. For example, we wanted an easy way to quickly develop data templates, so we automated a large part of the ignition UDT process. Nearly all of our PLC code is auto-generated from cause and effect matrices, which makes it easy to import new equipment configurations and push bulk edits to existing UDTs with just a few clicks. Over the hydrogen labs, researchers assess the performance and the durability of electrolyzers by running them for thousands of hours. With a custom load profile UDT, researchers upload complex load sequences for unattended stress testing, and our Python and SQL programming within the UDT applies the correct load. For electrical research, we built a custom oscilloscope tool in Ignition. Researchers can stream waveforms from any of the thousands of electrical meters straight to their laptop at up to 312,000 samples per second. These live insights provide critical visibility to ESIF researchers exploring new pathways for integrating energy resources.
My name's Ryan Ferguson. I'm a control systems engineer at the Energy Systems Integration Facility at NREL. At the heart of ESIF is the Research Electrical Distribution Bus, or REDB, a plug-and-play busway where equipment can be safely and flexibly interconnected across labs. With over 300 remote breakers to choose from, researchers need a safe, intuitive way to define experiments. One of the key requirements of this project was to create a new and improved recipe management system. The existing system required manually entering equipment and boundary IDs, which required in-depth knowledge of the REDB system. Utilizing Python and SQL, users now click on the equipment they need, and the system automatically calculates and applies electrical boundaries to prevent unsafe bridging between voltage domains. This vastly improved recipe creation time, safety, and traceability. In an effort to improve our response time to control system issues, we implemented an integrated issue tracking and change management system. Users can submit bugs or feature requests directly in Ignition. Changes are reviewed, approved, and linked to a site-wide formal management change process. This system has significantly reduced turnaround times for issue resolution and enhanced collaboration between researchers and facility operations. The new SCADA system allows us to historize all of the tags a lot faster and respond to safety events, knowing exactly what has happened in the lab, being able to see gas detection trends or electrical spikes.
Coolest part of the new system is definitely the Python, SQL, and just ability to do things in a custom manner pretty quickly. All of our custom tools have been great to work with, and without all of the easy scripting ability of Ignition, it'd be really difficult to push this project out. We can see all of our electrical distribution, thermal distribution, but we can also get easy trending for things like gas detectors, fire detectors, flow rates, temperatures, things like that. It just really helps us to have an awareness of what's going on in the building and just keeping the whole place safe.
My name is Shubhankar Ganguly. I work for Grid Automation and Control Group on Power Systems Research Group, and I'm a researcher here doing power hardware and controller hardware in loop experiments. I work in a variety of projects. One of them is grid modernization and grid security and resilience, and it's all part of the overall ADMS testbed project that is a vendor neutral, vendor agnostic testbed platform that we have here in ESIF. It's a very unique capability. Without SCADA, we cannot actually configure a single experiment here. The SCADA system we use for configuring and connecting different lab and equipments across the ESIF. We can connect different lab, different equipments through our research electrical distribution systems. This helps to bring unique capabilities that is very rare in the world, I would say.
My name is Curtis Buck. I am an electrical engineer here on staff on the ESIF Ops team. I am the team lead for that electrical side and engineering group, and I'm also the system owner for the research electrical distribution bus. We work with the researchers when they bring their project in to help them figure out how they're going to get connected, what they're going to get connected, and just everything around like the whole system of the project and what the ESIF can do for them, right, to achieve that project goal. So we're there to help them connect the cables and get all that equipment set up and make sure they meet all the various safety metrics, that sort of thing, before they ever turn on a power switch. The easy indication and the alarming helps us understand when problems are happening and helps us respond to those. You have that easy identification of issues. It allows us to really easily configure those experiment parameters so that we make sure that we're not getting two experiments cluttered together and that the paths are clear. The really handy feature that we have is the boundary setup, in that when you pick a piece of equipment inside of that recipe, it automatically aligns everything around it to not be allowed to work next to it unless you include it in the recipe. So as you're picking your pathway, it automatically creates what we call boundaries. And so two experiments can't be crossed together, because if you cross the electrical wires, that's usually bad.
This project took nearly 2 years of intense development, and we couldn't have done it without the experience and dedication of our team. Adam Bailey on PLC logic and code generation, and myself and Ryan Ferguson building the ignition system. Since launch, the feedback from researchers has been overwhelmingly positive. Project disruptions are down, usability is up, and innovation has accelerated. Each result from the lab inspires the next research question. With a high-performance SCADA system in place, the next iteration is only a few clicks away. And with every experiment, we advance NREL's vision for an affordable and secure energy future.
So far, everybody's been very happy with it. The alarm response, they like the trending capabilities, they like the recipe creation capabilities. It allows them to do more of their thing without involving us.
In the initial stages of this particular research and this particular project, we were not sure of what are the things that we are going to use, so we have to customize those recipes very quickly. In this case, we can very quickly validate the recipe, so it helped us saving a lot of time customizing the recipes for different types of scenarios, because in the initial stages of this particular project, we had to change it multiple times. Like even a single session, like 4-hour session, we changed it like 6-7 times. So that's why in the Unify archive, if we see, there are so many different recipes that I created like in a second.
The variety of busway and stuff that we have here is not found in most laboratories. Usually it's relegated to one lab as opposed to spread out through the building. But also power equipment and equipment in the utility space is expanding in uses. You know, you're seeing heat recovery modules on turbines now. And you're seeing a lot more of that thermal integration and the power integration and all those kind of things coming together in different pieces of equipment. And so it's important that you have a research facility that can meet that need. And the ESIF is, and that's why, you know, the SCADA and upgrading the facility is always so important, is because you're meeting those needs of the future before they're here.